Hello, and welcome back to AP Environmental Science. Today what we want to talk about is global climate change, and this is something that's going to come up a lot, and we've already talked a little bit about it, but I want to give you just sort of a formal kind of formal presentation about it. So the first thing that we need to think about is what naturally causes natural climate change. So here's your first question. Factors that affect climate include all but the following: properties of air, water, and land, seasonal changes in temperature and precipitation, uneven heating of the Earth's surface, or the orbit of the Earth. Well, seasonal changes in temperature and precipitation, remember, are part of climate. So those would be things that don't affect the climate, they are results of climate. Now, there are actually a lot of natural cycles that do change climate over time. And three big ones that actually are responsible for all kinds of fluctuation in the atmosphere are the Milankovitch cycles. And they are the eccentricity cycle. And what that means is that sometimes, in about over a 100,000 year period, the Earth is actually farther away at the apogee and perigee, right? And so, like, here's the sun. The oval that is our orbit squishes, elongating here, right? And then sometimes it becomes much more circular, which means we're closer to the sun. You can see how that would change the amount of the intensity of the incoming solar radiation. Now, the other thing that it does, we know that currently the Earth has a tilt of about 23.5 degrees, but about every 40,000 years or so, that actually comes up and then goes back down and then comes up and then goes back down. And so sometimes we're almost straight up. This is going to change where the most intense solar radiation is going to be, right? So obviously if it's up and down like this, it's going to be right on the equator. If it's at an angle, it's going to be just off of the equator. And then the last thing is the precession and of the axis. And what this means is it's a little bit like a top, right? If you have something that's spinning, the axis will actually make circles, right? And so the axis, if you were looking at the pole of the Earth, I'm going to use my mouse to do this, it would go like this. And so the tilt actually changes in the way it's pointed towards the sun. So sometimes the tilt is towards the sun, sometimes the tilt is away from the sun. And these obviously have huge ramifications, especially if they happen together. And there have been 5 major extinctions. One of the things that we're going to be talking about is, are we actually in a 6th? But that's not part of this conversation. But out of the actual 5 major extinctions, 2 of those were actually caused by global cooling. The other 2 were caused by global warming, right? And then one of them was actually caused by global cooling, but it was caused from an external event, which was an asteroid impact. The other ones were caused by either those cycles or massive volcanic activity. Remember, volcanoes cool, and so the 2 of the 5, right? And the actual 2, the ones caused by the volcanic eruptions or volcanic activity were some of the most severe. Okay. All right. Now, global climate change today. How it is happening, right? How do we know, and why do we care? First of all, you can see that the carbon dioxide has actually been kept between 200 and 280 parts per million for like the last 800,000 years, okay? And then recently, over the last just under 200 years, it has increased, and actually now it's at 400 parts per million. So we've actually topped 400 now. But that's been in the last 200 years. And so we do know that CO2 is increasing. Now, how do we know this? Scientists study climate change using all but one of the following techniques: analyzing ice cores from ancient glaciers, tree rings, analyzing seabed sediment in pollen and lake sediments, dissecting the leaves of tropical rainforest trees, or direct measurements in historical records. Well, leaves are temporary, right? And they certainly don't last tens of thousands of years, or, sometimes even 1 year. So we don't dissect leaves to find out, but we can take ice cores from glaciers, and those can actually take us back hundreds of thousands of years. And what we do is we look at the air that's trapped in the ice bubbles, and we can actually figure out what was the chemical content of the atmosphere. Tree rings will tell you, they give you a record of this, what's happening during the season, the water, right, all of that, and how fast they're growing for every season. Seabed sediment will collect various isotopes, and you can, in terms of like what was on the surface at the time, what was in the water, and that's going to change depending on exactly what's in the atmosphere, and also pollen. Pollen can be very helpful to know what kinds of plants, right? What kinds of plants will tell you what the climate was like. And then, of course, people have actually measured it, and we look at historical records. So, the models about what's going to happen as we start to see, this increase, not as we start to see, as we are seeing this huge increase, there are several different models. And so not all of these models are showing to be accurate, obviously. And in some cases, global climate change isn't as bad as many of the models predicted, but it is changing things, right? And so the other thing we want to figure out is what is changing. But first, true or false, the problem with climate change is not that it's occurring, but how rapidly it's occurring. Well, when you start looking at all these other climate changes, right, this is true, by the way, you start to see that these levels have fluctuated, right? So we've gone to about 200 to almost up to 300. But look at this. This is over tens of thousands of years, right, that you have these changes. But look here, this has been over less than 200. So that's got to tell you something about this being a natural cycle. The natural cycles seem to be very predictable, and they take a long time. This is like nothing that we've seen, just like nothing we've seen before. So when we start looking at these average temperatures, the natural temperature fluctuations should look like this blue line, okay? We are observing, right, this black line. And interestingly enough, okay, let's just back up for a second. There's carbon in the atmosphere, obviously, right? 780 gigatons are released from the ocean, for instance, every year, right? And 780 gigatons are absorbed by the oceans every year. But here's the difference. We, every year, put in an extra 30 gigatons. Well, that doesn't seem like a lot compared to 780, but it's every year, and that keeps adding, and that balance, right, it was 780 out, 780 in, is off now, because it's not really 780 out, because we're adding to it. It's 810 out, and only 780 in. So do you see how that works? Even though it's a really small amount, it's adding up as we keep putting it in and not taking it back out. So when you start looking at the anthropogenic, that's us, contribution, and you look at the natural changes, you see this red line, and lo and behold, that matches what we're actually seeing. So this is in fact happening, and it does relate to the carbon that we are putting into the atmosphere. Now, of course, we know that there's uneven heating of the Earth in general, but as global climate change happens, and by the way, this used to be called global warming because of this picture right here, right? The whole globe is in fact warming. But that doesn't mean that everywhere on the planet is warming. Some places are actually going to get colder. But we're talking about mean temperatures, and then we're talking about global temperatures. So overall, there's global temperatures, right? You can see, though, that as this changes, even the warming is going to be not evenly distributed. And it can be, if it's 0.5 or 1 degree, let's say, at the equator, it could be as much as 12 degrees at the poles, right? And that is going to affect the ice, which we've already talked about with the albedo conversation. Now, when we look at the U.S., you can see, look at these changes, right? Everywhere is changing by the time that you get past the 1960s, 1970s. Everything is changing pretty significantly. There are a couple of places that aren't, right? The Great Plains in the south and here in the southeast, but that's because you have this water here that helps mitigate some of the temperature change just because of the nature of sea breezes and things like that. But overall, everything's getting hotter. Okay, so what are going to be the oh, and by the way, I believe it's 13 out of the 14 hottest years on record have been in the last like 2 decades, just so you know. Okay, so what is going to happen with food? And I like this chart actually because it starts it shows you how severe these things will be, right? And so we're at 1.5. I'm sorry, wow, that's crazy talk. We're at 0.5 degrees. That's how much we've warmed now. So that's really not that bad. But once you start going up to 1 degree, right? So you've got rising temperatures. Now, what that means at first is that you may actually have a positive, right? Higher latitudes are being able to produce more food through agriculture. And as a matter of fact, France used to be the wine production. I mean, that's where all the great wines came from. And interestingly enough, England is now growing their own grapes and making their own wines. That has not happened before, and it's because their climate is more moderate. Now, the glaciers are going to disappear. This is going to be a problem, right? Coral reefs are starting to be damaged, partly because of ocean acidification, which we'll talk about in a second. Okay, but nothing's irreversible at this point. Ooh, when we start popping up to 2, right, you've got your rising intensity of all of your storms. Okay, that's going to add to it. Then as you start moving up, well, right here at 1.5, we started to see some crops will fail, right, as it gets too hot to grow. But you're still having this nice positive thing. But look in mind, as you keep getting higher, we'll start to see no positives, actually. Okay, now, this is just a nice little list of things that are going to happen. The temperature is going to increase, precipitation patterns are going to change, and sea level will rise. And frankly, sea level already is rising at a rate of about 3 millimeters per year, just as an aside. So what's going to happen? There's going to be health impacts, right? We already talked about agricultural impacts. Forest, we're going to change the composition of the forest because trees require a certain amount of precipitation and temperatures. There's going to be water resource impacts as we start losing glaciers, right? And as the rising sea levels intrude on aquifers. That is going to cause an impact on coastal areas, like flooding, for instance. And then, of course, we're going to lose natural habitat, and we're going to change natural habitat. And we're going to talk about all of these, but you can see that there are huge ramifications to these changes, and we don't actually know how intense they'll be. Is it going to be a little bit of change, or is it going to be a lot of change? And that's kind of the scary part. So, water, weather, and food. That's what we want to talk about. So, water availability. You can see that there are places that already have serious water shortages, but as precipitation patterns change, then there are going to be other areas that have serious water shortages that did not before. Okay, and water supplies for us, our water supplies are going to decline for 2 reasons. One, because we have the climate change effects, right? And this shows you the climate change effects as we move into, say, like 2050. Now, I will say we're also going to have water supply problems because we are depleting the Ogallala Aquifer and we are diverting rivers and things like that. Okay, so precipitation, that is going to change as well, all right? And so lots of places are going to become a whole lot drier than they were before. All of these things are going to have huge impacts on the agriculture, right? And so you can see that all of these places in equatorial regions are going to have decrease, although these places in the northern regions, they're actually going to have increases of crop yields. All right, now what about ice? Ice is melting. So where is all the ice gone? It's melted. It's gone into the ocean. And we're actually, this is a list of things where you're seeing all of these changes, but it's global. It's all over the place, from the Arctic to glaciers at the top of mountains. Yeah. And here are some glaciers that I just want to show you. This is the Muir Glacier, right, in Alaska. This was it in 1941. This is it today, or in 2004. Wow, apparently I can't read dates. All right, and this is Grinnell in 1938. This is in Glacier National Park, Montana, which used to have a beautiful, amazing glaciers, and there were lots of them. Now, this is Grinnell, right, in 2005, and it's actually smaller today. What that means is that Glacier National Park, in a very short period of time, will have no glaciers. And then this is Kilimanjaro. This is 1993. This is 2000, okay? And then if you look at this, this is 2009, right? So the snows of Kilimanjaro, not so much. Greenland, right? When you're talking about the permanent ice sheet, some of it melts in summer, right? And that's just part of summer, is that you have snow melt. You also have seasonal ice coverage, and you'll notice that The permanent ice sheet that is untouched, that does not melt, is shrinking every year. Okay. Now, having said that, right, there is right now in 2014 sort of a pause in temperature changes. And there have been some recent papers that have come out that have suggested that the deep ocean is actually becoming a carbon reservoir. When you start looking at these ocean currents, right, these surface currents where there is a lot of CO2 being absorbed are going to fall, right, but they're taking that CO2 with them. And so there's more storage capacity in the deep ocean. But the question becomes, how does this change the surface current, deep current relationship over time? And what does it mean when the ocean really can't hold any more CO2? And these are really good questions that we need. Okay, so the next thing that we want to talk about, though, are rising sea levels. There is higher, right, sea level than there used to be before. And so when we start looking at how that's changing, it's around 3.2, 3.3 millimeters per year. And you can see that you have lots of this is actually occurring around the equator, and part of that is thermal expansion, but you can see it's extending all the way down to Antarctica. Okay. Now, here's your question. Sea level increase is due mostly to melting glaciers and ice caps, aquifer depletion, or thermal expansion of the oceans. It is true that glaciers and ice caps are melting. They are melting faster than they've ever melted before. But the whole ocean is getting hotter. And remember, when things get warmer, they expand. So the bulk of this right now is because the water itself is expanding because it's warmer. So 3. And you can look at the changes in the sea surface temperature over the last 100 years. Pretty much almost everywhere has changed. Okay. Now, here's the other thing too. You measure ice, right? In the Arctic Sea, it's all ice. There's no actual water there. And when you start looking at the ice layers, right, the ice pack itself, you can see that even the oldest ice is thinner than it used to be, right? And this is a real problem in that this is the base of all of that ice. And I actually read somewhere that some of the naval submarines were reporting that they could pop up through the ice where they never could before. Okay, so sea level rise we know is caused in 2 ways. Thermal expansion, we've already talked about, and melting of land ice. Sea ice melt does not affect sea levels, it affects temperature, okay? And so that has to do with albedo. But it's the land ice that is going to raise the sea level itself. Okay, so here's your next question. Which of the following is not likely to occur as a result of rising sea levels? Loss of wetlands, agricultural flooding, cleansing and replenishing of aquifers, or some islands will disappear? Well, aquifers are going to experience salt intrusion. All of these other things will happen, probably. Clean aquifers, not one of them. They'll be saltier, probably. Okay, so effect on coasts, it makes sense. You're going to have more coastal flooding, you're going to have saltwater intrusion, and that's going to also create erosion of the coastline. Health impacts, right? So there are these estimated areas of deaths from climate change. Well, what causes that? Okay, all kinds of things, right? And so when you start looking at illness, injury, and death, right? When the food supply decreases, malnutrition and starvation. When you've got air pollutants, increase in respiratory diseases and heart failures, heat stroke, right? Disease transmission, the mosquitoes, right? Mosquito-borne illnesses or tropical insect illnesses, tropical vectors. Pathogens from warmer standing waters, disease, storms and flooding, they're going to make people move, right? Civil conflict when you're fighting over water or food, all of those things lead to illness, injury, and death. Yeah, and here is just malaria. When you start looking at the distribution of the malaria mosquitoes, right? Then you start to see, okay, so here are the malaria areas, but look. As these places, as the whole globe warms up, there are more places that'll have mosquitoes, okay? And then this is just what we've been talking about. Here are some examples for you to look at, okay? Now, deforestation and new habitat, ocean warming, and elevated precipitation, those are all things that are going to be related to climate change. Now, obviously, deforestation has other reasons too, and we're going to talk about that later on. But these are things right now that will also be related to global climate change. And so here you can see some of the things that are going to be problems in terms of disease, right? And then here is the prediction for environmental refugees from climate change. These are places where people could no longer get the resources that they need, right? And so where are the places that are most vulnerable? It is going to be the developing nations. Those are the places that are going to be most at risk, because those are the places that have the least infrastructure to deal with these things, right? Or systems, right? Okay. And it's not just us. It's going to be all biodiversity and ecosystems, yeah? And so threatened species, part of the threat to many of these species is not just us in terms of overhunting and overexploitation and other types of climate change, or other types of biodiversity loss, which we'll talk about in the next unit, but it's the climate change, right? Amphibians are very sensitive. They're they're indicator species. They're very sensitive to these changes, right? Water is changing, right? As water precipitation patterns are changing, you're seeing an increase in the endangered and threatened species. Okay, so what else? The oceans are going to acidify, right? And that's going to increase coral bleaching, which is the killing of coral. Remember, CO2 forms carbonic acid in water. As the ocean keeps absorbing more and more CO2, it gets more and more acidic. Now, ranges of plants and animals, they're going to be pushed into higher latitudes, but we're also going to lose the permafrost. That's going to thaw, vegetation is going to decay. That vegetation is going to emit methane and CO2 into the atmosphere, so the thawing of the permafrost actually is going to increase global climate change. And this is going to really cause problems for possibly 30 to 40 species, right? And so here's melting permafrost. These people's houses have crushed into it. And then here's a sad little polar bear not in the ice. All right, and then here's just a list of things that have been going on, right? And so what are the responses to some of these changes, right? And so you will want to read this. I'm not going to read it to you. So what are the big picture predictions? Okay. Here is a lovely flowchart that shows, yeah, as we have climate change, we're going to have the direct health impacts, and then we're going to have environmental and social impacts. And it's going to range from less water to economic losses, right, to actual property damage, to food losses, right? That's again going to have economic impacts and indirect health impacts. All right, and then climate destabilization. I like this. This was actually from the UK, and it's talking about all of the things that are going on, but I put it in here so you could actually have a nice little list of all of the things that are happening. And then when we start looking at the world being warmer, you can see all of these areas, and it gives you region by region some of the things that are going to be problematic. Okay, and actually in this one they're talking about, in some cases, just really quickly, there are going to be potentials for positive changes too, right? Solar energy, for instance, is all right here. So what are some things that we can do that are helpful? Reforestation here just south of the Sahara, that's going to be possible. So some of these things are positive in this picture. Which of the following would have the largest impact on the global climate? Increased release of methane from melting permafrost and wetlands, melting of sea ice, decreasing albedo, deforestation, or an increased demand for energy by a growing human population, or all of them? All of them. All of these are going to have a huge impact. So what we need to ask ourselves is, do we want to do mitigation or adaptation? Mitigation means that we're going to try and prevent it, okay? Adaptation means that we just deal with what's happening. So here, if we don't do anything up front, then we still produce the greenhouse gases. We have probably more serious climate change effects, greater impacts, and now we're going to have to adapt to those. If we try and produce fewer greenhouse gases, hopefully we would have a less serious climate change and less adaptation, although it's very possible that we've already reached the tipping point. And the other thing that is important to remember is that sometimes you can't just make changes. You have to take into account stability, right? So you have to take into account governmental stability. You have to take into account economic stability, right? Social stability. And so, for instance, if you were just to say, okay, we're not going to have any more gasoline, what kind of impact would that have, right? And those are the questions that you need to also be asking yourself when you're asking yourself about mitigation versus adaptation. So, which of the following methods for slowing global climate change focuses on cleanup rather than prevention? So, adaptation versus mitigation. A shift from coal to natural gas, to plant trees, to slow population growth, or to improve energy efficiency. Well, shifting from coal to natural gas, that's prevention, maybe. There's some real problems with that, and we will talk about the problems with the coal natural gas shift when we get to the energy resources unit. Slowing population growth, that's great, but again, you're talking about prevention. Energy efficiency, that is great, right? Prevention. To plant trees will absorb CO2 from the atmosphere. It's a CO2 sink. So that would be cleanup. All right, so what's been done? The Kyoto Protocol. The Kyoto Protocol was basically a giant failure. It said that developed nations have to start regulating their CO2. All of these things they have to cut greenhouse gases, but it did not include developing nations, right? Like China. And so it was not particularly successful, and we actually did not sign it, and we didn't ratify it. And some of the countries who did later on said, well, I don't really know if this is fair if China and India don't have to participate, because China is the second largest emitter of greenhouse gases. So if they're not restricted, other countries were like, well, I don't want to be restricted. So kind of fail. Now, it turns out developing countries are going to be the hardest ones hit. And we've talked a little bit about this as I was talking earlier, but I wanted you to actually have it in writing, so there's your slide about that. And then here are some resources. They're in the actual PowerPoint. If you want to go and check out some of the agencies that are dealing with global climate change, there you go. And that is it for this time. Please ask me any questions you have in class, and I will see you next time. Thanks for listening.